Ladies and gentlemen, welcome. Hello and welcome. My name is Faheem. Welcome to QubitsORG. It's a some tech channel, and today we are studying graphs, DSA. My endsems are in a few days, technically on Wednesday. They are on Wednesday. I am done with only one unit yet. I have 4 units to go, and unit 5 is all about graphs. Let me show you what the syllabus is. So this will be, I guess, a 90-minute session or so. I'll try to cover as much as possible. And I guess you'll be with me, street, whatever, history, archive, coding, something. Let's share the screen. Let's share our entire screen, not boom. There you go. This is our Unit 5 important topics: BFS, DFS, Prim's algorithm, Kruskal's algorithm, Dijkstra algorithm. Basically, this is all about graphs. We're done with this stuff: trees, BST, AVL, B-tree. I don't think I did. Heaps, hashing, I did. Yes, let's go. Alhamdulillah. 5, graph traversal, topological sorting, spanning tree, and then all this stuff. Let's start with a quick overview of graph. Okay, so we have ChatGPT as well, premium. We have uploaded it to it our syllabus, our PYQs, and basically we tell it to give notes plus PYQ question types and answers. So I have a good reference at ChatGPT. Let's go through it. Unit 5, graphs. Basic definition, write these in 1 to 2 lines. Graph G is equal to VE, where V is set of vertices and E is set of edges, ordered pair for directed graphs. Undirected graph, edge UV same as VU. Directed graph, edges have direction. Weighted graph, edges carry weights. Degree, number of incident edges. In degree, out degree, directed are counts of incoming, outgoing edges. Should I shut up? I don't know. Read if you want to. I'll do my thing. Paths, sequence of edges. Vertices, simple path has no repeated vertices cycle. I think I should turn on AC. Connected graph, every vertex reachable from any other for undirected cycle path starting and ending at same vertex. Representation, adjacency matrix. डीएफएस नाम की एक चीज होती है आई थिंक मैंने से पहले याद किया डीएफएस नाम की एक चीज होती है फिर सॉर्टिंग है भाई फिर अपना मिनिमम स्पैनिंग ट्री आ गया फिर डिजिक्स्ट्रा एल्गोरिथम आ गया क्रुस्काल आ गया और भी तो एक था प्रिम्स था ना ये प्रिम्स है प्रिम्स एल्गोरिथम I heard as well for some reason PYQ patterns BFS DFS topological sort find in degree MST shortest path extend algorithms. Mhm. Okay, okay. Okay, 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 okay. This should be enough. BFS, DFS. Let's start with hi. Let's see this. Okay, let's start. You can see my Chrome, Java, Python, APP, Advanced Programming, COA, Math, OS, DSA. Is there any option to stop sharing screen? Oh, there is one viewer. Hello, one viewer. I'm not sure how the audio will be when I am seeing a YouTube video, whether you guys will be able to hear it or slightly hear it or not hear it at all. Wow, my hands are mirrored. But I'm gonna watch it anyways. It is what it is. Uh, how are I think study with me streams are usually shut up. So like shut up. There's a timer at the side. Okay, I will start a timer. There's already a timer going on. You can see. I think this should be something like this. What do you say? Yeah, something like this. All right, there's a timer now as well. This is me. Would love to see myself on YouTube. But we got to lock in. Yeah, let's start.
However, it is valid to have one node to another node, and that node could point back to the previous node. An example of a directed graph could be a street map. Let's say you're working on a travel app, and each node is a possible destination. These single edges could be one-way streets, and these double edges could be two-way streets. You can move back and forth between these two destinations. There are two popular ways to represent a graph: an adjacency matrix and an adjacency list. With an adjacency matrix, we could create a 2D array, one row and one column for each node. If we need to check to see if there's adjacency between two nodes, we would first find the index of the node we're beginning at, let's say A. So we would go to node A, and then find the index of the node we're trying to travel to, so B. So row A, column B. If there are no edges, this would be 0. If there is an edge, this would be 1. So since there's 1 here, within row A, column B, well, there's adjacency from node A to node B. But if we take a look at row A, column C, this is 0, so there's no adjacency between A to C. But if there was, well, we would replace this 0 with 1 then. Now, there are pros and cons with a matrix. One of the benefits is that the runtime complexity to locate an edge is big O of 1. It's constant. All we have to do is find two indices. So we have to find the row and the column. However, the space complexity to store a matrix is big O of v squared. V as in the number of vertices that we have. But you could also think of that as n for the number of nodes. Big O of n squared. So since we have 5 nodes and 5 columns, we would have a total of 25 spaces. So the matrix is that it's very quick to look up an edge. However, a matrix uses a lot of room. So it tends to suit graphs that have a lot of edges. On the other hand, we have an adjacency list. An adjacency list is an array or array list of linked lists. Each element is a separate linked list, and each header within the linked list would contain a node. If there's adjacency between one node and another, we would add the adjacent node to our linked list. So to find adjacency between two nodes, we would find the node that we're starting at. Let's see if B is adjacent to E. So we would locate index B and travel this linked list until we find the node that we're looking for. That means there's adjacency between nodes B and E. Even if there's a node that is not adjacent to any neighbors, we would still want to add it to our adjacency list, just in case we do update it. Here are the pros and cons of an adjacency list. The time complexity to locate an element is big O of V. V as in the number of vertices. You can also think of this as n. So this would be big O of n. To locate an edge, we would first access the node that we're beginning at by an index. So let's begin at B, and we are looking for adjacency between B and E. Since each element is a linked list, we need to traverse this linked list linearly until we find the node that we're looking for. So in that way, it's linear. However, a benefit of a list over a matrix is that they use less space. The space complexity of an adjacency list is big O of V plus E. V for the number of vertices, aka nodes, and E for the number of edges. So yeah, everybody, those are graphs. A graph can be used to model a network. Each node is a piece of data within our network, and an edge connects nodes. So like I said, it's a popular way to model networks, which don't necessarily have any sort of order. So yeah, that's an intro to graphs. And in the next 2 topics, we'll create our own adjacency matrix and adjacency for the number of edges. So yeah, everybody, those are graphs. A graph can be a is that they use less space. The space complexity of an adjacency list is big O of v plus e, v for the number of vertices, aka nodes, and e for the number of edges. So yeah, everybody, those are graphs. A graph can be used to model a network. Each node is a piece of data within our network, and an edge connects nodes. So like I said, it's a popular way to model networks, which don't necessarily have any sort of order. So yeah, that's an intro to graphs, and in the next two topics, we'll create our own adjacency matrix and adjacency list. Hey, if you enjoyed this video, give it a thumbs up. If you have any ideas of where else you could implement a graph, let me know in the comment section, and of course, subscribe if you'd like to become a fellow bro. The node that we're starting at. Let's see if here. However, a benefit
streamers, आप लोग देखते क्या कर रहे हो तो आजकल I've been getting a lot of streaming content streamers on my YouTube shorts, including Sakura, Jason the Wayne, Senna, Kai Cenat, all that stuff. And they have a lot of clips which are pretty funny. Uh, but like it's pretty crazy on what their content is. Basically, their live IRL stream and they how they create content out of it and how they make it entertaining. Basically, a look into their personalities and a lot of stuff they do. But it's like a live sitcom. I I kind of love that stuff. I would love, I think, to do something like that. Though it requires a huge cent amount of authenticity, but it's very good in some sense. And maybe this could be something that will go there. Every streamer has his own audience, own stuff. Maybe I'm a streamer, tech streamer, doing some stuff. Back to studying DSA and SIMS. Okay, so graphs, modern networks, directed graphs, undirected graphs, adjacency matrix, O1, OVs, raised power 2, urgency list, linked list, time, OV plus E. They contain node, which contains data. They contain edges, which connects nodes. Nodes can also be called as views. Before we start spanning tree, how about we do BFS, DFS, graph, gates, smashers. I was listening to Jenny. Jenny is a YouTube channel, but her quality, I think he teaches good, but her quality of camera is bad, and like it's probably like older lectures. And the tone and all of it, it's kind of depressing and intimidating. You can get bored. This guy is very energetic, and I think I learned operating system and COA from him as well, some topics. So let's see. BFS, DFS. Bismillah.
सकते हो बहुत जरूरी है सब्सक्राइबर तो चलिए स्टार्ट करते हैं फर्स्ट ऑफ ऑल व्हाट इज द डेफिनेशन ऑफ ग्राफ ट्रैवर्सल द प्रोसेस ऑफ
I was talking about this guy, by the way. Yeah.
visiting and exploring a graph for processing is called ग्राफ ट्रैवर्सल की भी बात कर सकते हो ट्री ट्रैवर्सल भी हो सकते हो बिकॉज एवरी ग्राफ इज अ ट्री बट ट्री मे और मे नॉट बी अ ग्राफ बट एवरी ग्राफ इज व्हाट अ ट्री क्योंकि उसमें जो ग्राफ होता है उसमें साइकिल अलाउड होते हैं बट ट्री में नहीं होते तो ग्राफ इज अ बिग टर्म तो देखो यहां पे हम लोग दो मेन चीजों के ऊपर फोकस कर रहे हैं, एक तो विजिटिंग अ वर्टेक्स और दूसरा एक्सप्लोरिंग अ वर्टेक्स। मतलब जो ग्राफ होता है उसके अंदर आपको पता है कि वर्टेक्स होते हैं, एजेस होते हैं, ठीक है। अब मेरे को करना क्या है, दो चीजें मैं यहां पे करूंगा। एक तो विजिट करूंगा मैं, विजिट मतलब उस वर्टेक्स पे पहुंचना, उस वर्टेक्स पे रीच करना। जब मैं उस वर्टेक्स पे पहुंच गया, अब मुझे क्या करना है, एक्सप्लोर करना। एक्सप्लोर मतलब कि वो किनके साथ कनेक्टेड है, उसके नेबर्स कौन है। तो ये दो चीजें ही आपकी मेन चीजें, ठीक है। तो यहां पे हम इन दोनों को एक एक करके देखते हैं। तो सबसे पहले अगर हम बात करें ब्रेथ फर्स्ट सर्च और डेप्थ फर्स्ट सर्च में बेसिक डिफरेंस क्या है। ब्रेथ मतलब इस तरीके से, मतलब ये क्या करता है, एक एक करके सारे लेवल्स को फॉलो करता है। डायग्राम की बात करूं, जैसे एक ट्री यहां पे बना हुआ है, बिकॉज़ मैंने पहले बताया ट्री इज अ ग्राफ, एवरी ट्री इज अ ग्राफ, तो आप इसको भी ले सकते हो। तो देखो यहां पे अगर हम बात करें ब्रेथ फर्स्ट सर्च की, तो वो कैसे चलता है, वो ब्रेथ वाइज इस तरीके से। तो यहां जो ग्राफ होता है उसमें साइकिल अलाउड होते हैं बट ट्री में नहीं होते, तो ग्राफ इज अ बिग टर्म। तो देखो यहां पे हम लोग दो मेन चीजों के ऊपर फोकस कर रहे हैं, एक तो विजिटिंग अ वर्टेक्स और दूसरा एक्सप्लोरिंग अ वर्टेक्स। मतलब जो ग्राफ होता है उसके अंदर आपको पता है कि वर्टेक्स होते हैं, एजेस होते हैं, ठीक है। अब मेरे को करना क्या है, दो चीजें। एक तो विजिट करूंगा मैं, विजिट मतलब उस वर्टेक्स पे पहुंचना, उस वर्टेक्स पे रीच करना। जब मैं उस वर्टेक्स पे पहुंच गया, अब मुझे क्या करना है, एक्सप्लोर करना। एक्सप्लोर मतलब कि वो किनके साथ कनेक्टेड है, उसके नेबर्स कौन है। तो ये दो चीजें ही आपकी मेन चीजें, ठीक है। तो यहां पे हम इन दोनों को एक एक करके देखते हैं। तो सबसे पहले अगर हम बात करें ब्रेथ फर्स्ट सर्च और डेप्थ फर्स्ट सर्च में बेसिक डिफरेंस क्या है। ब्रेथ मतलब इस तरीके से, मतलब ये क्या करता है, एक एक करके सारे लेवल्स को फॉलो करता है। अगर मैं डायग्राम की बात करूं, जैसे एक ट्री यहां पे बना हुआ है, बिकॉज़ मैंने पहले बताया ट्री इज अ ग्राफ, एवरी ट्री इज अ ग्राफ, तो आप इसको भी ले सकते हो। तो देखो यहां पे अगर हम बात करें ब्रेथ फर्स्ट सर्च की, तो वो कैसे चलता है, वो ब्रेथ वाइज चलता है, चौड़ाई वाइज इस तरीके से, और फिर एक एक करके लेवल को कवर करता है। तो ध्यान रखना, एक लेवल कवर करेगा, जब वो लेवल कंप्लीट हो गया तब लेवल पे जाएगा। और डेप्थ फर्स्ट सर्च मतलब डेप्थ
Hi guys, what's up? Are you there? What's up, chat? Let's share entire screen. Oh, I wasn't sharing system audio up to now. I guess I'll share it now. Would you like to access first? Oh my God. So BFS, DFS understood what it is, but I'm not sure what kind of question we will have. Uh, Various representation of graph with their own example. Oh, that's interesting. Uh, Given below show its adjacency list and adjacency matrix. ये तो किया ही नहीं मैंने भाई. हाँ ये तो कुछ आसान सवाल आ रहा है. Describe depth first. ओहो, ये तो बस सिंपली सवाल आ रहा है. और कुछ क्रेजी नहीं आ रहा. In what steps vertices are visited? Okay, okay. BFS, DFS. All right, I get it. BFS, DFS का सीधी थियरी सवाल आ रहा है. BFS, DFS का सीधा थियरी सवाल आ रहा है. Yes, 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 baby, yes. मुझको जरिया दीदी की जरूरत है. Alright, BFS, DFS. फिर हम समझ तो आ गया. इसी को बोल देते हैं. और कहता है एडजेंसी मैट्रिक्स है. चैट जीपीटी को बोलते हैं भाई बीएफएस डीएफएस प्रॉपर आंसर with pseudo code, I guess. Not important. Page. Right. BFS, breadth first search BFS is a graph traversal algorithm that visits nodes level by level, starting from a source vertex and explores all its neighbors before moving to the next level. It uses a queue. Is a pseudocode for each vertex. Visited v false, created an empty queue, visited true, NQ while Q not empty, UDQ print U for each V in CU if visited false, visited true, NQ. Exact format ABDE, adjacency list is AB, A is BC, the hell, ADE, start from A, show this table, A, BC, A, breadth, breadth search. breadth में क्या करेगा ये भाई? breadth में करेगा मेरी जान ये लेवल बाय लेवल जाएगा. तो ए जाएगा, फिर बी जाएगा, सी क्यों जाएगा? ए बी सी डी ई, finding the shortest path, recursive version. Example A B D C E, start DFS at A, go to B, go to C D, backtrack to B, go to E, backtrack to A, go to C. Yeah, but what does that mean? I think I'm not able to show the graph properly, right? Okay, let's see if there's actually a graph. Yeah, there you go. So the nodes by applying topological sort. What the hell is that? Undirected graph. ये क्या होता है भाई? Hmm. पागल हो रहा हूँ। या आपका दिमाग खराब हो रहा है। ख्वातीन हज़रात, आपका स्वागत है इन अनदर एपिसोड ऑफ दिमाग खराब हो रहा है। यहाँ पे हमारे पास है व्हाट ऑर्डर आरपीएफएस स्टार्टिंग फ्रॉम व्हाट टैग। तो ये पीएफएस वगैरह अच्छे से समझ नहीं आया। हमें शायद जेनी के पास ही जाना पड़ेगा। तो यार
Hi guys, welcome back. Today I'm going to discuss with you how to represent a graph in computer. I'm going to discuss with you the most popular two methods for representing a graph in computer. Okay, the two methods are, first one is adjacency matrix and second one is adjacency 5. Then next is what? Where you can go. Hi guys, welcome back. Today I'm going to discuss with you how to represent a graph in computer. I'm going to discuss with you the most popular two methods for representing a graph in computer. Okay, the two methods are, first one is adjacency matrix and second one is adjacency list. First one is this matrix and second one is adjacency list. These are the most popular two methods. Okay, although we have more method, that is I guess multi-list is also there, but I'm going to discuss with you these two methods, adjacency matrix and adjacency list. Now how to represent a graph in computer. See, this is the pictorial view. You can easily draw a graph on this whiteboard like this, but when you are going to represent a graph in computer, then you have to use something. Okay, you have to use some methods to represent this graph in computer. So these are two methods, then one is matrix and one is list. First one is I'm going to discuss with you this method, adjacency matrix. So matrix is simply in mathematics, matrix is what? M cross n, where m is number of rows and n is number of columns, something like this, number of rows and number of columns. So in this case, let us take this example. This one is our graph and you are supposed to represent this graph using this adjacency matrix. Then how you will represent it? This adjacency matrix would be n cross n matrix, and where n is what? Number of vertices in the graph. Okay, now how you will represent it? This one is our matrix. This should be n cross n matrix, where n is what? Number of vertices. How many number of vertices? 1, 2, 3, 4, 5. Then 1, 2, 3, 4, 5 number of rows would be there and 5 number of columns would be there. This one should be 5 cross 5 matrix. Now we are supposed to fill out these entries. Now see, 1 to 1. Is there any loop? Is there any loop in this graph? Loop means the edge would start from the same node and would end on the same node like this. This would be a loop. If you have see, check out, you have any loop in this graph? No, you don't have any loop. That's why the diagonal elements would be 0. 3 to 3, 4 to 4, there is no edge, and 5 to 5, no edge. Okay, now check out 1 to 2. 1 to 2. Obviously, it is undirected graph. Okay, so this edge would be considered as 1 to 2 also and 2 to 1 also. Okay, 1 to 2. Yes, we have edge between 1 to 2. Then you can write down 1. 1 to 3. No, we don't have any edge, direct edge between 1 to 3. That's why it is 0. 1 to 4. Yes, we have 1 to 4. We have an edge. 1 to 5. No, we don't have. Now 2 to 1. 2 to 1. Yes, we have, because this edge is what? Undirected edge. So this is also considered from 1 to 2 and 2 to 1. Fine. 2 to 3. 2 to 3. Yes, we have. 2 to 4. Yes, we have. 2 to 5. No, we don't have any direct or any edge between 2 to 5. 3 to 1 you have. 3 to 1. No, we don't have. 3 to 2. Yes, we have. 3 to 2. See this one. 3 to 3. No. 3 to 4. Yes, we have. 3 to 5. Yes. Now 4 to 1. Yes. 4 to 2. Yes, this one. 4 to 3. Yes. 4 to 5,
we are studying
yes.
graphs,
5 to 1,
PSA,
no.
mining,
5 to
sensor.
2, no. 5 to 3, yes, we have. And 5 to 4, yes, we have. Fine. So you can simply write down like this. Okay, now you can simply write down the definition of this adjacency matrix is what? It is a matrix. You can say A, n cross n. We are representing the matrix with A, n, where n is the number of vertices, n would be the number of rows, and n would be the number of columns. And how you will fill these entries? A of I, j, this one is j, is equal to 1 if I and j are adjacent. Okay, see, suppose this one is I and this one is j. Let us take this one is I, we are taking, and this one is j. So you will write down A of I, j 1 if I and j are adjacent. 1 and 2 are adjacent to each other. That is why we are taking 1 to 2 is 1. A of I, j, that is A of I 1 and j is suppose 2. This one is 1. And I 2 and j is equal to 1. This one is also 1. Okay. Otherwise we would write here 0. Fine. Now next we will discuss what is adjacency list. See. Now this would be, as the name suggests, we are going to have linked list. Fine. And how many linked lists would be there? For each vertex, one linked list would be maintained like this. In this case, we are having how many vertices? 5, I guess. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Number of vertices are there. Fine. For each vertex, one linked list would be there, and that link
हेलो चैट, थोड़ा सा मैं बोर हो गया, थक गया। अभी तक हमने ग्राफ्स पढ़ा, फिर हमने ग्राफ ट्रावर्सल पढ़ा, फिर हमने सवाल देखा और हमें लगा हमें समझ नहीं आया, तो हमने एडजेंसी मैट्रिक्स, एडजेंसी लिस्ट भी पढ़ा। अब हम ये ट्रावर्सल वगैरह पढ़ेंगे क्योंकि इसमें एक सवाल आता है कि आप एक्सप्लेन करो ये कैसे परफॉर्म होता है। तो एक्सप्लेन करने के लिए अच्छे से समझना पड़ेगा। अच्छे समझेंगे, चैट जीपीटी वाला चीज भी पढ़ेंगे। चैट जीपीटी ने भी तो आंसर दिया था। एक क्या ये दिए थे इसने, टोपोलॉजिकल सॉर्टिंग वाली चीजें। इसने एग्जांपल जो दी मुझे वो समझ नहीं आई, बट आई गेस वर्किंग लिख सकते हैं। सूडो कोड दिमाग में रख सकते हैं। डेफिनेशन है एज डीप एज पॉसिबल स्टैक क्यू एंड देयर आर एप्लीकेशंस एज वेल। ग्रेट है भाई, ये हो गया। तो 8 नंबर भी आ जाएंगे। Then, ladies and gentlemen, we will have to do all those three algorithms. This is the least I have to do tonight before sleeping. And I guess I should do unit 3 say postfix infix conversions as well. उसमें stack और queue भी है. I think we can leave that क्योंकि postfix infix हर साल आता है इंशाल्लाह। इस पेपर में भी आएगा और मुझे आ जाएगा करना, तो इसलिए वो सीखना पड़ेगा वापस से। फिर 2 में से वो पॉलिनॉमियल वाली चीज कर सकते हैं। टावर ऑफ हैनोई, लिंक लिस्ट वगैरह वो सब पता नहीं आता है कि नहीं। वन कुछ नहीं आता है। सॉर्टिंग वगैरह वो वन कल अच्छे फ्रेश माइंड से करेंगे या किसी के साथ करेंगे, रूममेट वगैरह के साथ। 2, 3, 5 हो जाए आज, बड़ी बात होगी। 3 भी थोड़ा हो ही जाए तो अच्छा रहेगा। 3 में क्या इंपॉर्टेंट टॉपिक है भाई? 3 में ये स्टैक वैक है भाई। इनफिक्स पोस्ट फिक्स करेंगे चुपचाप करके, और कर नहीं है तो टावर ऑफ हनोई करेंगे। फिर टावर ऑफ हनोई क्या होता है भाई? टावर ऑफ हनोई कुछ तो ये है कुछ टावर ऑफ हनोई ऐसा भाई। हमें बचपन में इंटरव्यू में पूछते थे कौन सा कलर है। ये यहाँ पे क्यों आ गया? DSC प्रोग्राम टावर ऑफ हनोई डिस है क्या भाई ये? वो तो बताओ। A mathematical puzzle and fundamental problem. Source auxiliary. Only one disk can be put at a time. I think ये मैंने पढ़ा था कभी। Recursive mode is one disk and complexity Python. Give pseudocode would be if n more one n minus one. Interesting. Shouldn't be that difficult, I'm sure. Abdul Bari, 10-minute video. Should be good. Yeah, then we can do this polynomial thing as well. Joseph problem, sparse matrix, फिर linked list। काफी बड़ी चीज है तो नॉट श्योर मैं कितनी हद तक कर पाऊंगा। वो फिर ये तो सारा ही है, इसको अच्छा खासा टाइम लगेगा। हम्म हो सकता है, सही है। फिलहाल यूनिट 5 हो जाए बड़ी बात है, लेकिन 3 में से भी कुछ हो जाए तो ज्यादा ही अच्छा है। 2 और 1 भी काफी ज्यादा है। समझे? सही समझे। Stop sharing. Is there any way to pause streaming? I think there used to be pop out chat. What does that mean? Oh, that's nice. I don't know. Is there any way to pop out. अरे क्या रहा है? Sorry, is there any way to Hmm, what is there any way to pause stream, share screen, mute, don't have access to this feature, dashboard, okay, okay, yeah, okay, yeah, how do I pause the stream? Okay, how to pause YouTube stream? Doesn't look like there is a feature. Ladies and gentlemen, we had gotten disconnected, or was it a break? I don't care. Do you care? Let's start studying again. With the DFS, let's do it. And at least one algorithm or something. Then we can take a break, eat food, and then resume MST, Prim's, Kruskal, Dijkstra, topological. This should be, ये तो होना है by hook and crook. और फिर पोस्ट फिक्स एंड फिक्स भी कर ही लेते हैं इंशाल्लाह। और यार वो तो मतलब आई थिंक वो हो जाए, ज्यादा तो नहीं होगा वैसे, बट फिर वन कल फिर वन करना चाहिए फ्रेश माइंड के साथ, या अगर उनमें से कोई मुझे सिखाएगा दोस्तों में से, फिर टू भी करना है अच्छा खासा। फिर थ्री बचा कुचा है भाई। हाँ हो जाएगा। अज्यूमिंग कल मैं जल्दी शुरू कर दूँ, और फिर रिवाइज भी करना चाहिए। हो जाएगा इंशाल्लाह, हो जाएगा। वेरी गुड।